Thank you all for the welcome. As Tim mentioned, I'm Simon Kubica, Product Manager.
Hey, and I'm Michael Oates, an engineer working on Forge.
Now, we're so excited to be here, and we can't wait to finally share what we've been working on with you all. Personally, I think Forge UI is by far the most awesome part of what Tim and Joel shared today. It's a complete revolution in user interface and experience. Now, it wouldn't be possible to give a talk on Forge UI without Michael. As Tim mentioned, he really knows this inside and out, put together the very first prototype, and yeah, I can't wait to share what we've been working on with you this week. Now, we have three main agenda items for you in today's talk. So I'm going to start us off with a level set on the underlying why behind our decision to build Forge UI. Then I'll be handing over to Michael, who's going to be going deep on the technical intricacies. It's a great talk if you're into your front end. And then to wrap up, I'll be sharing what's been on our minds for the future of this incredible framework. Let's get started. Now, exposing UI in our products today starts with the trusty iframe. Now, these come in a few different shapes and sizes, and of course, you won't just find them in Jira, you can find them in Confluence, Bitbucket, and Trello as well. So these are dynamic. The actions that you take change the view. And they're also fundamentally external to the Atlassian platform. Iframes embed views from your own external apps and services living in the cloud. Now, we also have a newer kind of niche extensibility in the front end, the static declarative modules. These extensibility areas, like the glance and Jira toolbar, restrict you to a tight design pattern. So that's a quick look at what we have today, and it means you can break down our story into fundamentally dynamic and static declarative modules. Now, we'll dive back into declarative iframes in a moment, but on those smaller static experiences, they actually have a ton of untapped potential, and they were part of the genesis of Forge UI. There are a few reasons for this. Firstly, development with them is incredibly easy. There's no fiddling around with JavaScript libraries, styling, or layouts. Secondly, they're native experiences. So Atlassian delivers the code that's executed in the browser, no iframes. This means there's no need for an external service to integrate into the user interface. And this brings substantial trust benefits for security-conscious organizations. We're going to be talking a little bit more about that in a moment. The problem, though, is that there hasn't been a way to leverage these benefits across an entire application. The way I like to think about it is that there hasn't really been a middle ground in our UI extensibility story. These static declarative modules are small, and they don't provide a toolkit sizable enough for you to deliver the comprehensive user experiences that your customers demand. They've been built as an augmentation to dynamic modules, not as entire experiences. And once you use a dynamic iframe, you're on the hook for the styling of each pixel. As I mentioned, working with those JavaScript libraries, on the hook for the security of your app. And so that's the reason why we're introducing flexible, powerful declarative modules to our UI extensibility story today. It's called Forge UI, and it's a declarative UI framework that enables you to quickly and easily build those native, flexible, and trusted user experiences that your customers have been asking for. Now, you write Forge UI directly in your FAS environment, which handles the heavy lifting and delivers a really thin client library to the host, interacting with it for state management, among other things. Now, we've prototyped our very first set of components for the purposes of testing Forge UI in the real world. You can display these in the new editor in Confluence, and we've already been amazed with what some people are coming up with, not just at Atlassian, but also upstairs in the labs. And we've only covered a fraction of the components that we hope to support, so really incredible so far. So to really dive into that why, I think it comes down to three fundamental pillars. We think building user interface should be quick and easy. You should be able to develop rapidly with really powerful components that let you leverage all of the work that we've been doing to improve and enrich what customers are doing in your applications. Second big reason is trust. So this really closes the loop on the FAS and data storage story for Forge, allowing for secure apps with no data egress, no need to embed something in from an external service. And thirdly, enables us to finally achieve those native API cross-platform experiences, no matter whether you're on a desktop, on a mobile, iOS, Android device, or a tablet. So diving into those really quickly, you can declare components that work out of the box. It's going to enable faster loading times for you as well. And we're going to handle things like resizing and cross-platform compatibility for you. As Tim mentioned in the keynote, those version upgrades are going to come straight in without you having to do any more heavy lifting. It's all about getting that componentry in, getting that logic the way that you want a user to interact with the app, and then we're going to be bringing those changes to you for free. On trust, again, closing the loop, no egress applications, enabling you to finally build apps that stay within the Atlassian cloud for the most security-conscious enterprises, irrespective of whether you're a team of one or in a larger group. That burden of trust and security really moves to Atlassian with Forge UI and the broader Forge set of tooling. On cross-platform, you can write your code once and run it absolutely anywhere, and we'll take care of that resizing. So potentially have a desktop issue glance that can render 3 columns, and then once you move into a mobile, because that's not going to be an ideal experience for the user anymore, it's going to switch. And we handle that. You don't even really need to test and make sure that it's working correctly. It's truly, truly amazing. So those 3 things, quick and easy, trust, cross-platform, really the pillars for Forge UI and how we want to move forward with this. So I'd like to invite Michael up on the stage. I hope that was a bit of context on the why that's going to be helpful, but this is truly an incredible deep dive that's about to begin, so please give Michael a round of applause. Good luck, mate.
Thanks, Simon. We've had a really great team working on Forge UI, and it's been really exciting to see it evolve from its initial prototype to the technology that we're able to share with you all today. At its core, Forge UI is a data format that describes how to render a user interface in a platform-independent way. We've coupled it with a protocol that describes how user interactions that occur within the front end can be handled by code running within our functions infrastructure. And then on top of this, we've spent a lot of time investing in a framework that allows you to intuitively build apps using component-driven development with the state managed by us. Now, before we deep dive into how Forge UI works, there's probably a few important concepts we should quickly cover first. The first of these is markup. And markup effectively describes how to compose a user interface from a set of platform-native components. Now, as you would have seen in all of the previous presentations we've had, you write markup using JSX. We then process this with our renderer, and we're able to serialize the result into JSON, which can then be sent to the client. The wire format for Forge UI is actually reasonably similar to the Atlassian document format, or ADF. ADF is used throughout Atlassian's cloud to power the rich content that we produce from the Atlassian editor. Similar to ADF, we use a type property as a discriminant, and it controls which component gets rendered within your markup. We then have a set of properties which can influence how the component gets rendered, as well as allowing you to embed children components. We then have effects, and effects are what allow you to respond to user interactions. And effects are basically, they're what allow us to use Forge UI for more than just that sort of static rendering that you would have seen before for the declarative UI, and instead allow you to use it for much more dynamic and much more interactive experiences. Effects allow your app to interact with the surrounding product, and they're an integral part of Forge UI, powering our event and render loop. And then we have state, and state was a much later addition, actually, to Forge UI. But its importance started to really become apparent as we started to build more and more complex user interfaces on top of Forge UI. We needed a way by which we could track what was visible in the UI and the data that we'd already loaded. This is necessitated by the fact that functions are inherently stateless. You can't track information between invocations easily. But our tools take advantage of this state to build an awesome developer experience, automatically rehydrating the information you need to render your app and to handle callbacks, allowing you as an app developer to instead be focusing on building your app using the patterns that you're used to using today on the web. So one of the concepts that's been really popularized by modern web development has been the idea that your user interface should actually just be a function or a transformation of your app's state, where changes to the state of your application should be reflected within your user interface. And this is a model that works really well for Forge UI, where your markup is a function or a transformation of your managed application state. And we're able to handle events and use that to drive changes to your state and then update your UI accordingly. So as part of building Forge UI, we set out to build a large set of apps to prove that it was possible to build useful and meaningful apps on top of the tech that we have available. And so one of the apps that we had built, and that I'll be using as an example today, is an appointments app that can be used by a team to list a set of appointment times they have available for other teams to book, as this is actually a pattern that we use with several teams around Atlassian. So as you can see within my app, I've got a table, and in there there's several rows, each showing an appointment time, the status of that appointment, and a button that allows you to book that appointment time. Now, in any interaction with this app, there are three main systems involved. We have the client, which in this case is a React-based renderer running within the browser. But for example, for a mobile device, it might be rendering instead to native components. We have the invocation service, and you can think of this service as something like an API gateway. It covers a lot of the cross-cutting concerns we have for handling function invocations, like, for example, permission checking or routing requests to the correct backend function. On top of this, we layer a whole set of functionality specific to Forge UI that allow us to do things like transform and validate markup on the way in and out of your function. And then finally, we have our functions infrastructure. And our functions infrastructure is where the code that you will write and bundle with our libraries ends up getting run. And as you would have seen, we're using a serverless pattern for this. And that means that we're spinning functions up and down in response to demand and giving you a clean slate for every function invocation. So the lifecycle of an app typically consists of 4 stages. The first being that we need to resolve metadata about apps so that we know how we can actually go about rendering the apps. From there, we're able to start initializing your app and kicking off our render and event loop. So for the appointments app, before I can actually go about doing anything with it, the first thing we need to do is we need to start discovering information about that app so that we know how to render it. And this is handled by an API that we host within our invocation service. This API filters the list of apps against some set of criteria and returns to the client metadata that you've put within your manifest that allows us to render parts of the app. So in this particular case for the editor app, when we're using the quick insert menu, we're populating the information in there, in particular the title and description, straight from your manifest. After we've actually inserted the appointments app into the document, we can then start bootstrapping the app. And to do this, the first thing we need to do is the client needs to assign a unique identifier to this instance of the app. This stable identifier is used across multiple invocations as it allows us to track the data associated with your app. Within the editor, then, we embed this identifier so that within the document so that all of the editors within collaborative editing are able to share that unique identifier. At this point, then, we can start actually kicking off the render of your app. And we do this by dispatching what we call an initialize effect from the front end through our invocation service and to your function. This initialize effect is effectively telling the function that we want it to render a clean slate or the initial state of your app. Alongside this, we include information about the location in which your app is actually running, and also any additional metadata we need to render your app. So that would include things like the currently active user. Sorry. And at this point, then, we can actually kick off the rendering process. So up here, we've got a component from the appointments app, in this case, the root component. We're using a use appointments hook here, and the use appointments hook is actually building on top of the use action hook to add some additional business logic. One of the really cool things about the hook model is it's very easy to compose hooks together and to build logic on top so that you can share it across your app. With the list of appointments that we return from this, we then map these to a list of custom components, in this case, a list of appointment rows, and we embed them within our appointments table. Now, one of the great things about using JSX to power our markup is that we're able to hook into the transformations that are offered by Babel and by TypeScript. And we can insert our own custom JSX factory instead of using the ones that are normally for React. The custom factory we inject allows us to use our renderer and effectively emit JSON as a result of the function. So we converged very early on using JSX as the format for our markup for a few key reasons. The first of these being, as you would have seen, it's significantly less verbose than writing the wire format directly. It's also a lot easier and a lot more intuitive to compose a user interface from a combination of components you've written yourself and components provided by us. And finally, and perhaps most importantly, the tooling and static typing available for JSX is fantastic. Having autocomplete and validation just magically available within your editor is immensely useful when developing your app, as it means that you need to context switch far less between your development environment and documentation. And I did mention static typing. So we do actually support also using TypeScript, and we have all of the typing set up for our components. So if you want to use that, it's there. Now, at this point, we need to take that component, that app component, and we need to turn it into the markup so we can actually render it in the user interface. And our renderer is responsible for doing this. Our renderer renders a single component at a time. It tracks the component it's currently rendering, because this is important for tracking state using hooks. It also means that we're able to pause execution if we need to, so that we can do things like fetching asynchronous data. When a hook's encountered, we then check the currently rendered component, and we're able to pause if necessary. We then get the resulting state, and we're able to embed that within our state map. So each component is expected to return a tree with some combination of either Forge UI provided components or components written by yourself. Any Forge UI provided components are able to be directly serialized into JSON, whereas for custom components, we need to actually go and render those and serialize those first. As part of serializing Forge UI provided components into our markup format, we insert a key into each of the components. And this is actually done during our Babel transformations. The reason we do this is it allows us to much better track the state of components within the user interface in the front end. Additionally, we also take any function declarations you've got within your markup, and we turn them into a serializable representation that we can use when we need to call back into your function to handle an event. This representation contains a component key, which lets us navigate to that component, and then the property on which the callback's defined. And all of this happens transparently to your function. As far as you as an app developer should be concerned, you can literally just pass around callbacks, and they'll be called transparently for you. So at this point, the renderer is then able to expand any other custom components it finds recursively until it's able to serialize the entire tree, and it's ready to send it back to the client. So once the server-side runtime has finished rendering the interface, we're able to respond with a render effect. And the purpose of a render effect is to tell the front end, can you please replace the contents of the app with what's just been emitted by this function invocation. On the way through the invocation service, we're able to validate and transform parts of the request to get it in the right format to be consumed by that particular client. Now, one of the really cool things we can also do at this stage is we're also able to intercept the response and to return something else if we need to. So for example, if your function crashes, we can actually return a well-formatted error to the front end. Or maybe we determine that you actually need an authorization flow to be completed for your app. And so instead, as you would have seen in previous presentations, we can just show a button to kick off an authorization flow. All of this happens transparently for both your function and also for our front end too. It doesn't necessarily have to differentiate between things returned from your function and things returned from us. So once the markup's returned to the client, we can actually then kick off the process of turning this into a user interface that someone can actually interact with. So to render the interface in the client, we recurse through the returned markup, and we use it to instantiate components. We bind properties from the markup to the component properties, and we also set up any callbacks we need to. So for example, within the appointment sample app, the buttons are essentially instantiated from Atlas Kit buttons, and we're binding the text property there and setting up an on-click handler for you. Now, it's important to call out at this point in time that we're rendering directly into the DOM of the host product, and that's really important because that gives a whole set of advantages to both the apps you're writing and also to the products. In particular, it helps a lot with load times because we don't need to wait for several round trips to load and then pass all the resources that we need. It also gives us interesting opportunities to experiment with technologies like server-side rendering in the future. We also don't need to instantiate multiple iframe contexts, which particularly on resource-constrained environments, can actually be a bit of a problem, for example, mobile phones, just due to the memory and CPU usage overheads. We're also able to cache the results if we want to, which can be useful when navigating around to quickly present a state to the user. Also, really importantly, the UIs that we're writing are much more tightly integrated with the surrounding product. And so that means that things like, for example, content resizing just works out of the box. We don't have to mess around with inserting custom elements into your iframe and tracking the resize. Instead, we can just rely on the browser to do this for us, or the native platforms to do it for us. Likewise, pop-up content, like for example, modals or selects, just work out of the box as well. Anything which overflows the bounds of that frame or relies on Z indexes to work, we just get support for that automatically. It also means that the visual appearance of what you're writing is much more consistent with the surrounding product, and changes that we make to the surrounding product can be reflected very, very quickly without any work on your behalf. And finally, and perhaps one of the more exciting things as well, is that we can start to leverage some of the more complex components we have set up. So for example, you would have seen in the keynote this morning that we're looking at if we can support the Atlas Kit editor. And that would be an amazing thing if we could support that with very, very little code on your behalf. But at the same time, you would get all of the amazing services we've got backing that for things like emoji and mentions. So once we've actually rendered the UI, now we've got a user interface that's ready to be interacted with, and we can start to handle events. So let's say, for example, I want to book the first appointment time from 9 till 9:30. So I go and I click on the attend button, and it enters into a loading state. So something that's important to call out here is that we're actually layering functionality on top of the Atlas Kit components to make them have sensible defaults. So in this case, that means that we're hooking in some tracking of loading states into the attend button for you. Once we've actually handled that, we're able to then go and look up the handler definition, and we use that when we start to dispatch the event effect. So likewise with rendering and initializing, events are handled by dispatching an event effect from the client through the invocation service and to the backing function. This effect contains information about the handler that we just saw, and it also contains a list of arguments. And those arguments can be used to pass additional information back to your function. So you can think, for example, if you were writing a form, we can actually pass back field data as part of this. We also pass back the state map, which is quite important, and I'll get to that in a minute. So invoking a callback within your code is actually quite challenging, as we don't retain the UI between invocations. And so in order to get around that, before we're able to do anything else, we have to rehydrate your application tree. We do that by rerunning the render method for your components. But we're able to leverage the fact that we already computed all of the state we needed to on the previous invocation, and so we can actually shortcut fetching remote data. Once the tree has been completely rehydrated, we're then able to invoke your callback, and we can track if any changes are made to the underlying app state. If there are any changes to the underlying app state from there, we're able to re-render the affected components, re-serialize your app, and send it back to the front end. At which point we're able to kick off the render process again. And so, like with the initialize effect, in response to an event, the way we update the user interface is we're effectively returning a render effect, telling once again that we want to replace the contents in the front end with what we've just emitted in our function. But it's important here, we're actually returning an array of effects here, not just one. So in the future, we may also allow you here to return additional effects in addition to the render effect. And that could be used for cases like, for example, if you wanted to open a dialog, or let's say you wanted to show some flag somewhere. You can think of effects as filling a similar role to the JavaScript bridge that we use within our iframes today. sorry. There we go. So once the markup gets received on the front end, we're then able to kick off re-rendering the UI to show the changes. In this case, updating the free to occupied. Any subsequent changes are able to trigger and process events in the same fashion as we just saw. So something that's really important to call out at this point, though, is that we've moved the computation for Forge UI out of the client and into the backend function. And so, as you're probably thinking, latency and computation time become much more of an issue. So to keep UIs as fast and responsive as we can, there's a couple of things that we're going to need you to do where possible. In particular, keeping in mind on latency. So not making remote calls unless you know you're going to need the data, and taking advantage of our state management to keep that data that you've fetched available. Also, trying to minimize how many dependencies you're bringing into your code. Since we're using a serverless model, that means that we're paying that cold boot time whenever we're starting your function up. And having a lot of JavaScript can actually contribute a non-significant amount of time to your boot up. That said, we've designed Forge UI where possible to try and minimize actual and perceived latency where possible. We've done this through building some loading states directly into some of the components, as you would have seen, and also making some significant improvements into how much overhead that we actually have on function invocation. That said, I'd like to say, though, we have got a lot of opportunities to further speed this up in the future. And we've been discussing a lot of changes we can make both to Forge UI and just our infrastructure in general. Some ideas we've been floating around is the opportunity to inline effects directly into your markup so that we don't have to make a round trip to your function in order to handle interactions. And also things like, for example, batching up interactions as they happen on the front end if they happen in quick succession. But realistically, the latency is critically important to us, and having responsive apps is critically important to us. And so we're going to be working on this and investing in this a lot as we keep to developing Forge UI. And so this is the state of Forge UI as it is today. And I think we're really excited to see what sort of apps people are able to build on top of the technology that we've got available. I think something, though, that I'm really, really excited about is we've got some great technology here, but some of the opportunities that it's going to give us in the future to expand and unlock new opportunities for our ecosystem. So I'm going to invite Simon back up to the stage now, and he's going to talk through some of the bigger ideas that we've got for where we want to take Forge UI in the future.
Thanks, Michael. Let's give Michael a hand. That was incredible. Absolutely amazing. Just one of many Atlassian built apps that you're going to be able to see in Tim's showcase later today. Let's start talking about the future. So this technology is still very young, and it's of course going to change and evolve as we try to iterate on it. It's something that we've only made available internally for a select few people a few weeks ago, as Joel alluded to earlier. So there's still so much that we're looking to accomplish. I'd like to share with you some of the nearer term, medium term, and longer term, really exciting pieces that we've been considering for the future of Forge UI to get it ready for you guys. So one of the very first things, and I hope that this goes without saying, is we want to advance our component set. We want to build on what we've prepared so far, but the components that we target and the order in which we ship them, it's going to be defined by what all of you are asking of us as developers. We're looking forward to having you all work closely with us and share the components that you need to deliver enriching user experiences. So whether that's an inline card component or just declaring an Atlassian editor and having it work out of the box, we want to hear from you and figure out what it's going to take to get these apps running on Forge UI. Next, I want to highlight that we see the future of this framework as innately cross-product. We're seeing the problem space of security and the opportunity of native cross-platform support. This is something cropping up across our entire suite of products. And we have been working with product teams to think about the next steps for Forge UI, not just in Jira and Confluence, but also more recent members of the Atlassian family like Trello and Opsgenie. Stuck here, one moment. There we go. For the future of our security model, we're continuing on with our mission to keep security of third-party apps at the forefront. And this can extend to giving administrators more control over where their data goes. As an example, we could enforce rules for functions running within Forge, allowing admins to control the domains that an app can speak to. Now, this extends to Forge UI as we completely control the rendering, meaning we can add the option for these same restrictions to exist in the front end as a set of validations before rendering. This closes off data egress mechanisms like loading images from untrusted domains. These are loopholes that the iframe content security policy could solve at some point, but we believe that we have a solution in the shorter term. Now, moving on to new platforms. Mobile extensibility is something that we're very excited about at Atlassian, but we've historically found this quite difficult using our existing UI model. Apps which are built for the web don't always scale well to the resource constraints and interaction patterns of mobile devices. You don't get to hook into that native API and tap in automatically to features like dark mode or greater accessibility granularity as those things become available. So from the start, to fix this and give you those sorts of opportunities, we've been designing Forge UI to be as independent of the underlying platform as possible. It's been deliberately built with strong contracts in place between our functions, our infrastructure, and the product front end. As a result, we can swap out the renderer for a completely different platform without needing to change or re-engineer a lot of the functionality on our end. This means absolutely no work on your end. Now, one of the tools that we've used to facilitate this has been to consolidate as much functionality as possible into our smart invocation service as a transformation pipeline. It's able to apply transformations and validations to Forge UI documents. Now, at the moment, we have a web-focused renderer available for you to try today upstairs in the labs, but it would be possible to swap it out with a native mobile renderer, and it's what we're looking to do to achieve some of those benefits that I just alluded to. Now, we actually proved this out during the initial prototyping phase of Forge UI, where we built support into the Jira mobile app natively. Now, a mobile renderer could render interfaces with native components that fit that look, feel, and interaction pattern of the surrounding application, along with those overarching user settings for accessibility. Now, this would all be as seamless as possible for you, the app developer. You shouldn't need to know where your app is running. Focus on that functionality and benefit from the fact that your app is running on multiple devices where users need access to that information. Now, as you already know, as part of the Forge project, we've made it possible to build an app without the need to run any of your own servers. Instead, we host and manage within our own infrastructure. Now, this works great for code running within our functions. Although in the future, we'd like to extend this to hosting for static assets too. This would open up things like Atlassian hosted icons, illustrations, and other media for your apps inside Forge UI. This also closes the loop on that trust story as well. You don't need to go out for any sort of untrusted images, bringing everything within the Atlassian model if you so choose. Now, deploying to this could be handled as part of your normal deployment. Could have something like a CDN folder being marked as a capability within your manifest so that it's incredibly easy for you to consume. The lifecycle of this content could then be managed so as to ensure that we're always using best practices for things like caching to keep apps as speedy as possible. Could also provide helper components or utilities to automatically resolve that cached content for you. Again, all on our side to keep you focused on your business logic. Another benefit of a content delivery network is that could also unlock support for a hosted iframe powered by Forge UI and served by the Atlassian cloud, integrating with our function hosting infrastructure for API calls. Now, through hosting, these iframes would be set up with all of our learnings and best practices built in, including good security defaults through the content security policy and good performance through static caching. It's just one potential avenue for further iframe support on top of what we're already supporting today. And this is something crucial that I want to highlight. Ultimately, we know that for some particularly rich and complex apps, iframes are the best fit. You have access to the full API surface area of the browser. So we're continuing to make the dynamic iframe experience awesome, inside and outside of Forge UI, in addition to always looking for new ways to allow you to build better applications. And of course, as a caveat to wrap up our thinking on the future, we don't know exactly what it holds. We're experimenting ourselves and expecting some seriously awesome apps from you folks. We're also evaluating closely in our early testing to stay close to any opportunities for Forge UI to add additional value on top of what Michael and I have already shared today. So as a reminder, the Forge beta program is going to be available this year for you to try out on your own machines at home and at work. We're super excited to get it in your hands as early as we possibly can and hopefully build on and achieve some of those future state ideas that we have in mind by then. And of course, in the meantime, if you can't wait to get your hands on things, we have the hands-on Forge Labs upstairs. I've already seen a few faces upstairs trying it out with some amazing feedback, 14 components ready for you to use. And you can display those within editor apps and, of course, work cross-product as well across Jira and Confluence. So thank you so much today for coming in and hearing what we have to say about Forge UI.